welcome back to my channel. Thank you very much for joining me. For today's video, we are going to talk about end behaviors of our functions. And here we have two steps for you to help you to identify the end behavior. We say use the degree, which is the highest exponent you're given. So if you have x to the 6, that's going to be your highest degree. Is this degree odd or even? If you see x to the 3rd, you know that that's an odd number and the 6 is an even number. You say use the leading coefficient, meaning is it a positive number or a negative number? So the positive or negative will tell you how your function will be shaping, especially if you think about a good example could be your y equal x squared graph. So your y equal x squared graph, you know, is going to look something like this, right? Where it's like a u and the negative of that, so that's y is equal to x squared. And if you think about the negative of that, it's going to be the flip about the x-axis. So the negative of that would be y is equal to negative x squared. Alright, so if you think about the leading coefficient being positive or negative, it will also guide you in that sense. So I have some steps here. I have the key here for the leading and the degree, how they relate to each other. I'm going to explain that to you in just a minute. Alright, so if you look at the first graph that says y equal x squared in the red, you see that the positive should be here. You'll see that for the top graph in the red, the leading coefficient of x squared is 1, so that's a positive number. The exponent here is 2, which is an even number. So if it's positive and even, the end behavior should be going in the positive infinity region. So we say they're both trending upwards. And this happens for all even exponents. So if you see x to the 4, x to the 6, x to the 8, or whatever the case is, you know they're both trending upwards. If, for example, you see the negative, y equal negative x squared, you realize that your function is flipped against or reflects against the x-axis. So they're both trending downwards. So we say if it's even and if it's negative, the both end behavior will be going in the negative infinity region, hence making it both going down. For leading coefficients that are positive and the degree is odd, a good example of this could be y equal x or y equal x to the 3rd power or y equal x to the 5th power. It's up to you. But I'm going to do this one, y equal x. So y equal x is a graph that we all know how to draw from heart, right? And so y equal x, we see that the leading coefficient here is positive. The degree is also odd because it's just 1. So if it's positive and odd for the degree, we say 1 is going down. So this one should be going downwards. As you can see, the arrow pointing down, and the other one should be pointing up. So it's basically saying as x approaches negative infinity, y is approaching negative infinity. As x is going to positive infinity, y is going up to positive infinity. And the same can say for y equal negative x. So if we want to flip the graph around, I'm going to put it in red so you can see. And it's not drawn to scale, so guys don't penalize me right now. If you see y equal negative x, for this one, if the leading coefficient is negative, so negative 1, and the degree is odd, like the one you see at the exponent here, they're saying that your left side should be trending upwards and your right side should be trending downwards. So they're saying as x approaches a negative infinity, your function is increasing its positive region, and as x approaches positive infinity, the function is trending down in the negative region. So if you can remember this table, that will be very good for you. But if you cannot, always go ahead and draw the y equal x squared and the y equal x function to determine the odd and even and how the graphs are looking. That's the simplest way I can tell you to remember it. X squared function and y equal x. Draw them out and you should see them popping up right in front of you. Let me know if this makes sense for you. I tried to make it as quick as I could. So leave me a comment below and let me know what you think about these. And I'll see you on the next one.